So we are going to start with the noise, which is a part of Unit 1. And in communication, all systems are affected by noise. Ideally, we say that my system is noise free, but actually, practically, no system is noise free. All the communication systems are affected by noise, and the definition of noise is except the desired signal, what other component you have, it is going to be noise. To make it as simple as possible, whatever signal you require, except that whatever other things you have, it is going to be noise. So you might hear an FM music from a station using a headphone. The music will be very clear, but as if you start traveling, you will end up hearing a lot of noise. So the actual signal itself will be completely overdone by noise. So noise can be defined as a signal which is completely going to deteriorate my signal, and anything except your desired signal is going to be noise. So noise can be natural, it can be man-made. So natural noise, if you're going to, if it is raining, you will have some noise. If a thunder is coming, it will have some noise. So these are natural factors which will contribute to noise. And artificial noise source like power lines, so the power lines which carry the 230-volt power supply voltage to you, that will create a hissing sound. So in America they use 60 hertz, so it is given example 60 hertz, but India we are going to use 50 hertz. That is also going to be the sources of noise. So only when amplifiers were invented, these noises were noticeable, because only when the amplifier started amplifying noise also, their importance, the more importance was given to noise, to analyze what type of noise is going to degrade the performance of your amplifier. The amplifier is not an intelligent device, it doesn't differentiate between signal and noise, right? So it will amplify both signal and noise. So only when after the invention of amplifiers, the noise theory actually got a big boost up, so that the different types of noises, the different mathematical models of noises, everything was invented only after the amplifier was completely designed. So if you are going to cascade more amplifiers, the noise will also multiply, which at one stage it will be like your noise will completely override your signal. So such is the effect of noise. You cannot ignore the effect of noise in a simple manner, because when you are going to use multiple amplifiers for amplifying a signal, if one amplifier is going to have introduction of noise by some means, it is going to have a cascading effect, which means that at the output of the final amplifier, the noise level will be very, very high compared to your signal level, which will completely corrupt your signal. So in audio systems, you may notice you will hear a constant hiss sound, which is since you are hearing it using headphone, you can constantly hear the sound when there is a noise in the audio signal. When you attend a call, when you make a call, when you watch a movie, or when you hear music, or you hear some information from FM station, this noise can be experienced. You will hear a continuous hiss. The sound will be like a snake hissing. But in video, you can even see the noise in the video very clearly, because visually you are seeing. So there might be snow, complete blackout. You might have a black screen, or you might have a white screen looking like snow, or sometimes you will have a blurred moving image. So all these are typical forms of noise which exist in audio and video systems. So, as I said, the noise sources were not defined clearly until the amplifier was invented. After the amplifier was invented, these three people, without them, this communication theory will not exist. Nyquist, Johnson, and Schottky. So these three people are the gurus of noise. So without the contribution from these three people, you can never understand what is noise. So if at all we have a mathematical model to analyze noise, it is because of the complete work done by Nyquist, Johnson, and Schottky. Okay, so they were the people who identified what are the different types of noise are available in the circuit, and how I can mathematically model it, and what can be done to keep the noise under control. So these three people, the contribution is going to be enormous in the field of noise. Obviously, it is a very dry area, but these people worked on that to ensure that the noise is completely modeled by a mathematical equation.